Hello and welcome. Today on the bench I have a microphone calibrator from Bruel Kjaer. It's model 4231, it's broken, so I'll see if I can fix it today. This is a very high-end microphone calibrator, but what is a microphone calibrator? When you're doing critical sound measurements, well, you need to make sure that your tool is reporting the right sound pressure level. And in order to do that, you need a microphone calibrator. Now, this is broken, so I can't show you yet, but this is my own microphone calibrator, and this is my own measurement microphone. It's a Biodynamic MM1 microphone. It's an omnidirectional microphone. It means it captures the sound 360 degrees around the capsules up here. And I'm using it to do sound measurements in cinemas. Now, to make sure I get correct numbers from the software I'm using, I need to calibrate the microphone. And in order to do that, I'm applying this little adapter. And at the press of the button, this calibrator will play either a 94 dB tone or a 110 tone. All I need to do is to plug the microphone into the calibrator. Obviously, the microphone needs to be connected to my software or tool, whatever you're using. Turn on the calibrator through the button, and then you can calibrate your software or your tool or your sound interface so that it reads what the calibrator is outputting. In my case, usually 94 dBs. Now, these was purchased as broken by a friend of a channel, actually one of my supporters on Patreon. You know who you are. Thank you so much for supporting me, also for sending something to repair. And let me take a second to thank all my supporters on Patreon and on Buy Me a Coffee. Thank you so much. Now, as I said, this calibrator was sold as broken, so let's see what it does. Now, the way this works is identical to my own calibrator. You have an opening here, you plug your microphone in, and then you have two buttons, one to turn on the reference tone and one to change between 94 and 110 dBs. Now, there are two batteries here. So yesterday I gave it a go, and I think I saw a little glimpse of life on the power on LED. Let's see if it does it today. I haven't touched it overnight. No. Today is completely dead. Yesterday I saw a little glimpse of LED when I pressed the button just the first time. So the first thing to do obviously would be to check the batteries. And I can check with the multimeter to see if I'm reading anything here. Well, I'm reading 1.58 on this one. And what about this one? Yeah, 1.58. And I'm checking at the contacts. So that should also mean that the batteries are making contact. Now let me quickly remove this adapter. And let's make sure that those contacts are actually working, though I've just measured the voltage on it, but I just want to make sure. Now, there is blue stuff, which means at some point the previous batteries leaked. So that's definitely something we want to look at. But the point is, I measured 1.5 volts at the contacts, so that shouldn't be our problem. But maybe as a first thing first, let me try and clean those contacts. And also, I think I'd like to swap the batteries. These are Kirkland batteries, and I believe here in the UK, Kirkland is like a budget store. It wouldn't be the first time I've got batteries which are working with the multimeter, but they're not actually able to supply the proper amount of current for the device they're used in. That being said, I'm sure that this is a very low power device, but you never know. I think I can just test another couple of batteries. I'm going to use Varta batteries. They are known for being very good batteries. Everybody from the retro community knows about that. And let's see if by any chance anything has changed. Oh. What? Okay. Wait a sec. It worked for a second and then it turned off. Was that it? Number one. Number two is this. I don't think this is supposed to work indefinitely until the battery goes flat. Okay, I think we still have some problems, though. I'm a bit surprised that two new batteries, they massively improved the outcome, but I can see that the on-off button is kind of working and the level selection doesn't really do anything. Well, I'd say this is a very good start. I have a feeling maybe it's just a power issue, but we will know in a minute. Now, I couldn't find a service manual for this product, but there is a user manual which I think brings some important information to the table. The first important part is this section of the tool itself. These are the two batteries. This is where the microphone would go. And this is the inside of the unit. We have the circuit board here at the bottom. And then obviously we have a speaker, which is playing the test tone. But we also have a reference microphone. So this tool is actually listening to itself and self-calibrating it based on some calibration which is done at the factory. And I think I also see that to dismantle the whole unit, I have to remove the screws which are under the batteries, and then the top shell will come off and hopefully reveal the circuit board. There is a very nice block diagram here, which is very, very helpful. This is the microphone to be calibrated. And as I said, there is a little speaker in here, but there's also a small microphone which goes into a feedback circuit, which is going back to the control circuit. Now, I'd imagine this tool is completely analog. I'm not expecting to find anything digital inside this thing. And I've actually found something pretty interesting. On-off button. Press the on-off button to start the calibrator. To save the batteries, the calibrator will automatically switch off again after a short time if you have not fitted the microphone. So it looks like this tool is able to determine whether the microphone is being plugged in or not. And if it doesn't sense a microphone, probably using the internal feedback microphone, well, it switches on straight away. So maybe I've already fixed this. Let me try and plug my microphone and see if it stays on. Now, unfortunately, my microphone is smaller than the adapter here. So I'd imagine probably if I just put my hand on top, that should be enough for the microphone to sense that something is in. I guess it's a matter of signal level. If it's too low, it means the opening is completely open, the sound is going out, and I don't know, that's my only guess. So let me try. I think I'll fit this back in, and then we'll try and turn it on, and I'll stick my hand in front of it. Yeah, this is working. Oh. Okay. Well, I don't. This is clearly the fastest repair ever. And it's just working. And the tool here is able to determine whether there is something inside the opening or not. And it will turn off automatically. So this is working totally fine. And I don't think it was the oxidation, which we need to fix anyways. I think it was the batteries. Because I think yesterday I gave it a little try and it wouldn't do anything. I think it's just very inexpensive batteries. No, this is not working. Oh, it's not even fully in. Okay, well, yesterday I did scrub a bit the contacts, but it didn't do anything, so I assumed there was an issue with it. Fantastic. So, to my friend, you got a bargain, because whoever sold this at a very low price didn't realize that they just needed to scrub the contacts. Now, what can I do? I don't think I'm not gonna make a full video of this. Of course, it doesn't make any sense. There's nothing to see. And honestly, this is working. I don't really want to open it, though. There is some corrosion there, so maybe it just makes sense to open the tool up and make sure there's nothing nasty happening. I guess those contacts can be removed, so I can clean them a bit better, because obviously there's still some green stuff on top. Those are chromed, like they're plated. I don't have anything to plate them, so I can only sand them lightly, but obviously that will expose the metal underneath, which likely is going to rust at some point. Yeah, let's open this up. We'll have a look at how it's made inside, and then we'll move from there. Okay. Well, I think I can see what the problem is. It's just battery corrosion. The voltage from the battery is going to the contacts, through the screw, down into these brass posts. The brass posts are, I don't know, somehow plugged into the PCB, and they are connected together. So this is the ground, and then I guess we have a battery here that connects to the other one in series, and another battery here. So that makes 3 volts in between these posts. And obviously with this amount of corrosion, it doesn't really work all the time. So me fiddling around with new batteries just restored a little bit of connection until it actually started working. These little copper things, I think they're designed so you can remove the lid of the unit without removing the screws. So the screws and the contacts and these bits, which I believe, I'm not entirely sure what they do. I think the idea is they stay in place, so you don't have to recompose this thing every single time. I'll have to try and understand how to put it back together when it's time. And there is a little flexible cable here going to these two buttons. And I believe someone has been here before because I see it hasn't been pushed in entirely. I mean, this part here is slightly open. So maybe someone opened it, they saw the damage and they thought, okay, we'll sell it as faulty, we'll make some money and we'll leave the problem to someone else. I mean, that's not a big deal. Fixing these contacts is not going to be easy because I can sand them, remove the corrosion. But as I said, that will also remove the plating, and I believe these are probably copper underneath, which means they will oxidize pretty easily. So this time I think I'd like to explore the option of replating this at home. These are very small, so I won't need big containers with lots of water and chemicals, so I'll have a look online and see what I can find. Alright, a few days have passed for me and I've decided to go ahead with the nickel plating. So I watched a few videos to educate myself on what to do, so I went ahead and purchased 2 small stripes of nickel. Nickel can be expensive, so I think these were supposed to be like 13-15 pounds, something like that, but the seller must have made a mistake and this is what I got instead. 10 by 10 centimeters by 1 millimeter thickness. So I went ahead and cut a couple of stripes, which I'm going to use for this experiment, and I'll keep the rest for future experiments. The first question that comes when you buy nickel from eBay is it actually nickel? Now, I don't have specialized tools to check, but I did a simple test. I put this stripe in salty water for about a week because I forgot at some point. But before dipping it into salty water, I scratched the surface because what can happen sometimes is that it's not actually, well, it's nickel on the outside, it's coated with nickel, but it's copper or iron or something else on the inside. And you're expecting to see some corrosion if it's not nickel. And nothing absolutely happened. There's nothing happened on the edges. So it actually looks to be genuine nickel. Even while I was scraping it with a blade, it felt much more soft than metal, the regular iron, and I understand that it's also a sign that this is not metal, it's actually nickel. So we're going to use those 2 stripes for our little process, and it's going to be a simple process, last famous words. I'm going to use this little glass container as we only need to recoat 3 of these clips. You might be able to see that this one is in the worst shape, then we got this one. This is a little corroded, but since I'm recoating it, why not? Replating it, why not? This, to be honest, is totally fine, so I think I'm going to leave it in peace. Also because to nickel plate those things, I'll have to remove the existing plating, which I think is chrome plating, and I'm not entirely sure how to do that using chemicals or anything, so I'm going to use manual means. So that's going to take a little time, but meanwhile, we need to make a solution of nickel acetate using the nickel stripes here. That's going to be a greenish solution that's going to be used later on to actually nickel plate those terminals. So let's begin with that. I'm going to fill in this container with some distilled vinegar, and I understand that this is the acid that we need as a base for our little experiment. Then I'm going to add a little bit of table salt to increase the conductivity of the vinegar. How much? I'm not sure. I think the video I watched said like a tablespoon, but they were making a big container, so I don't know. I'll just make an educated guess here. That's probably enough. Now, first thing first, I'm not an expert when it comes to chemistry, even though it used to be one of my favorite subjects when I was going to school. So I'm not an expert, I don't consider this a tutorial, it's just me showing you what I'm doing. But as a general rule, I would say make sure that if you decide to do this, that you're doing it in a well-ventilated room. There will be some gases released during the chemical process, and some can be flammable, like hydrogen, for example. Now, my understanding, and again, don't quote me on that, is that the amount of hydrogen being released is minimum. But once again, just make sure that your room is very well ventilated, mostly because I can smell vinegar now. Then I'm going to place the nickel inside the container, and I'm going to use a couple of alligator clips, which are connected to my bench power supply, one to the positive and one to the negative. Now, the instructions said to use 30 volts. I don't have a 30 volts bench power supply. My bench power supply can only do 15 volts. So that's what we're going to use. And I will use something like, I think I will begin with half an amp and then I'll move to 1 amp maybe. My understanding is that it really depends on the temperature of the water. When the water is getting a bit too toasty, you might want to reduce the current. Otherwise, again, it will get too hot. I got my power supply set for 15 volts, half an amp. Let's turn it on and see what happens. And it's definitely working. You can see the power supply is actually limiting at 5 volts and the voltage has dropped to 5 volts because obviously to get 15 volts it would be too much current. I can see bubbles on the stripes. Yeah, you can see that on camera and that is great. So we'll have to wait until the solution, I think it's a solution. If it's not, just leave a comment down below if you know more about chemistry than I do. I believe you are making a solution, but I'm not sure. Eventually, this will turn greenish. So I understand it's going to take probably about an hour, 2 hours, probably with less than 30 volts is going to take more time. I'm not sure because anyways, even if I had 30 volts at 500 milliamps, I'm only doing 5 volts. So I don't think that's relevant. But we'll see what happens. Now, we just have to wait. Two hours later, and we got this very nice and deep blue color. So I think this is enough. And meanwhile, I turn up the current to 1.5 amps, and the temperature here is still totally fine. I think it's about 40, 45 degrees, so nothing to worry about. So I think this is done. It's time to turn off the power supply, remove the nickel, and close the jar. I can see that the nickel plate connected to the negative wire, it's peeling off. Oh, look at that. I don't know whether this is like pieces of nickel, so probably I'm going to leave it there. Or maybe it's some impurities, or maybe some oxidation, which was on top of the stripe of nickel. I don't really know. If you do, comment down below, because again, in 2026, chemistry is definitely not my main skill. I mean, I hope that this doesn't mean that this is just coated with nickel and that this part here I'm touching now is not nickel. It's a bit kind of weird that this whole surface here is peeling off and there's something which is like unaffected behind it. It's also interesting to see that the back of the strip is more or less unaffected, and also the other one, I think the other one is receiving the nickel. Yeah, I think I can see something on top of it. It's difficult to show on camera, but there is a texture on top of the stripe here. And what happens on the other side? Well, it's kind of unaffected. So yeah, it's mostly happening on the sides which are facing each other. And now that we've got a magic potion, the next step would be to properly clean these terminals. I'm going to use mechanical means. I have some sandpaper. This is 1200. I have 600 here. I also have some higher numbers if needed. The goal is going to be to have the surface as smooth as possible. If the surface is not smooth, well, the plating is not going to be smooth either. Not a major concern in our case, but why not try and do that right? So let's get started. And this is the outcome. It's not perfect, but it's a very small piece. It's a bit difficult for me to polish it a bit more. Once again, if the surface is not perfectly smooth, well, the nickel will basically follow the imperfections of the surface, which in our case is not a problem. This is a battery terminal. As long as there is nickel and there is no corrosion, everything's going to be fine. Now, before we proceed, let's do a quick test with a copper coin. Now, for plating, the item which needs to be nickel plated will need to be the cathode, so connected to the negative cable. And for the anode, I'm going to use the cathode that I used to make this green solution. And thank you to Reddit, I realized that this is not nickel peeling off from the strip. This is nickel which has come from the other strip, and apparently nickel doesn't like to nickel plate other nickel, there's lots of nickels here, which is also probably very much oxidized, so it makes this little structure on top. So this is not nickel peeling off, it's nickel building up. It's impressive. Thank you Reddit for clarifying that for me. So I'm going to use this one, because obviously it's got lots of extra nickel on top. I don't know whether it's the right thing to do or not. This is going to be my positive, and this is going to be my negative. So let me set it up, and we'll give it a go. I've got the coin ready. This is how it looks. So let's dip it into the solution. And let's turn on the power supply. I will start with 500 milliamps, just to make sure. 3, 2, 1, go. Yes, I can see bubbles on the coin. Now, ideally, you don't want the bubbles to be there, because the bubbles will affect the quality of the plating. The bubble will be in the way of the plating, and you might end up with some pits and a rough surface. So in theory, you should stir the solution, move the piece. I'll try and do something. Once again, we are not looking for perfection here. These are battery terminals. So I'd imagine if I just move the coin a little bit. I just make sure there are no big bubbles on the coin, and that should help. The power supply, once again, is limiting at 500 milliamps, and I've got 5.2 volts going through the electrodes. So once again, there is no need for like 30 volts power supply. You will never get to 30 volts. Unless you set it to silly amps, I guess. But my understanding is if you want a nice finish, you need to keep the amps as low as possible. But it will take more time, so it's a matter of compromises as usual. Well, only a few seconds have passed, but I honestly think this is already working. So let me turn off the power supply and we'll check. And would you look at that, this is working. It works totally well. I am impressed. I wasn't expecting just a few seconds, and it's already nickel plated. So, well, I guess we can start with the actual pieces that we need to nickel plate. So let's begin. Now, before I begin, I have some acetone here, and you need to be very careful with that. I'm going to rinse the pieces into acetone. The plan is not to have any grease on them, because I believe the nickel will not plate greasy surfaces. There we go. If there was any grease, I'm sure this is enough to dissolve it. There we go. Acetone will evaporate within seconds, so I don't think you have to worry too much about it. I'm going to hang the pieces using this piece of copper wire, like this. Perfect. And this is going to be connected to my negative. There we go, we are ready to begin. Since the coin worked so well, I think I'm going to use 500 milliamps, and probably I'm going to wait for like 5 or 10 minutes just to make sure that the thickness of my nickel plating is adequate. Because after all, the batteries are going to rub on the contact, so you want the nickel coating to be wear resistant for a number of years, of course. So let's turn on the power supply. 3, 2, 1, go. And yes, it's working beautifully, I hope. Okay, well, something is not working. I'm not sure. I'm wondering whether I actually removed the, I think it was chrome plating entirely, because I see something is peeling off here. Okay, well, I'm not sure exactly what's happening, because where the, let's say the terminal is, where the battery is going to touch is totally fine. But here is not. So I'm wondering whether that's because of the amount of bubbles created by the fact that there is the negative connection touching there, which is somehow disrupting the coating. Maybe I need a better connection, or maybe I just need to wait a little bit. I'm not sure why that is happening, but that's exactly where the bubbles are coming up. I think I want to try with less than 500 milliamps. I mean, this seems very fast. It seems a bit too aggressive. So let me try with something like 100 milliamps. So let's try with 100 milliamps. I don't know, to me it feels a bit more controlled. Well, it's been a while at 100 milliamps for about 2 volts, so let's see what's happened since last time. So the plating is working, but something definitely happened when I had the power supply of 100 milliamps. Something either peeled off or more likely nickel deposited too fast and ended up doing what happened on the what is now the anode. So it made a little, I don't know, it deposited it in that weird way. It looks like something is peeling off. So I think I will sand that off. It's probably going to be totally fine. I'll sand that off and replate it so it doesn't really hurt. Now, the fact that the surface is dull, I understand this is kind of expected. If you want to make it shiny, you just buff it up at the end of the process and it will be shiny. To me, it doesn't really matter as long as it conducts electricity with the battery and it doesn't rust or oxidize or affect the conductivity over time. I don't matter. So let me, let's say, reset this area here at the front and also at the back, which is not too bad, but why not? Let's just reset this part. Well, the good news is that I've sanded this part a little bit, not too much, with a 1200 grit sandpaper, but I don't see the copper. That means that the coating is working and is definitely gaining some thickness. This is great. So let's continue with 100 milliamps on this small piece. It works totally fine, and I'll wait a little bit more, just to be on the safe side. Alright, well, this is the final result. I think I can be pretty happy with it. I don't see any issues, but now I polished it, so it kind of went away. You might be able to see here, there was some sort of peeling off effect as on the plate, of the nickel plate I showed you before. I don't know whether I didn't sand it off properly after the first attempt or whether it happened during the second plating. But it looks totally fine. And most importantly, it's reading perfect conductivity. These probes, they do read 0.1. So this is perfectly fine, and I think they're going to be perfect as battery terminals. So let's continue with the next 2 pieces. This time, I think I want to start with something even lower, like 50 milliamps. After all, in the video I watched, they turned up the current to 3 amps, but it was a very long piece of metal, and I can imagine that 3 amps are 3 amps. So you have 3 amps regardless of the dimension of the piece, and if the piece is very small, well, you have 3 amps of nickel ions just depositing on the part itself. So I don't think there is a one setting that works for everything. For these very small pieces, and maybe with this very high concentration nickel acetate, maybe it's okay to use a lower temperature. I will start with 50, and I might want to turn it up after a little while because it looks like the reaction is a little stronger at the very beginning. Again, I don't know why, and if you know about these electroplating properties and the chemistry behind it, please do leave a comment down below because I'd love to hear about that. Well, it's done, and I'm pretty happy with the outcome. The terminals on the left are the second batch, and this one is the first batch. I believe the first batch is a bit rougher. The surface is a bit rougher. Also, I polished this, so that might be the reason. But if I'm not mistaken, it looks like there is a little bit more nickel on it. I started at 500, I continued at 100, while these ones have always been at 50 all the time. I think this is plenty of nickel, to be honest, and again, I don't really care about the finishing. So yes, apparently you need to adjust the current depending on the size of the pieces that you want to plate. And it totally makes sense to me, so just bear that in mind. If it's a large piece, you might want to go up with the amps until you see some bubbles. If it's a small piece, you might want to start very low and maybe do an educated guess and look at the reaction and see how it goes. Now the fun part, putting it back together, and I guess I'll have to go back to my footage, because I don't think I remember how to do that. Actually, no, I have forgotten we have a little more oxidation to remove corrosion, actually. For this one, I think a little bit of vinegar will be fine. Alright, it's back together. I had a look at my footage and I think this is the right orientation. I'd imagine it's impossible to install it the other way around, because obviously if I install this incorrectly, well, the polarity might be incorrect, but this seems to be fine. Let's plug some batteries and see if it works. It's working. Oh yes, of course, this was turning off automatically because it doesn't sense the microphone. So I just have to cover the cavity here. Well, it's done. Not really a repair. I appreciate if you follow my channel, you're used to me fixing things, and this was working. It was just a little bit of corrosion. But nickel plating is something that I had been trying to educate myself with for a long time. I believe someone suggested nickel plating when I was refurbishing the Macintosh, and I said, really, I don't want to have to deal with big containers and solutions and chemicals, but for something small like this, it seems to be surprisingly easy. I'm going to store the nickel acetate solution and the nickel plates for future projects. It's a simple process. For small items, why not? So I guess this is it for today. I hope you enjoyed the video. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel and my second channel if you like this kind of things. Don't forget I'm on Facebook and Patreon. The links are down below in the description. There is a free tier on Patreon, so no excuses. But if you don't want to support me on Patreon, well, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to buy me a coffee, I completely understand. And most importantly, I hope you enjoyed the video. Well, thank you for watching. I hope you have a great day, and I hope to see you again soon here on my channels for my next videos. Thank you very much, and goodbye. Bye-bye.